Hello, Math 30-1. You are now applying the expertise or continuing to apply your expertise with transformations. And we don't want to consider that as a separate entity because transformation can happen with all functions. So in the previous section, we were focused on the A and B transformation. And in the A and B transformation, that was about amplitude, or in the case of our general discussions with transformations, that was about vertical stretches. But you also talked about the B value, which was about period, but in our general discussions with transformations, that was about horizontal stretches. So you worked on stretches. In this next section, we are going to focus on C and D. And what they do, well, we know what they do. When we see a value like 30 degrees or 30 inside there, how does that affect the graph? Well, from our work with transformation, you guys are experts at that, we know that x has been replaced with x minus 30, and therefore that would be a horizontal translation to the right of 30 degrees. We can see that there's y has been replaced with y minus 2 in terms of replacement. So that clearly means that this has been vertically translated up by 2. And if we continue what each of these are, obviously this one has gone 60 degrees to the left, and it has gone down by 1. Oh, we need to be careful with the next one, right? Be careful. We can see clearly that this is 45 degrees right, but because they were tricky in this one, it's with the y has been replaced with y minus 45, and therefore that actually means 45 up. All right, so we're just continuing on with what we know. We're just doing it with sine and cosine now as well. And we need to remember these words. We have special words for these horizontal shifts. They're called phase shifts. And the vertical translation, we're still calling a vertical. We don't have a special word in Trig for that. All right. So without using a graphing calculator, preferably, I'd like you to go and look at each of these equations and then discuss their horizontal and vertical displacements or changes, right? So you've done that. Now you come back, and what's happened to each of those? Well, there's nothing happened to sine x. In the next one, it's pi over 4 right and 0. So you can check those values and ask questions in class tomorrow. Most importantly, we need to be aware in general of when they have general equations, they like to do things like that. So what's happened? Because it's minus c, it's gone c to the right and d to the left, and those are just general. One little note that I'm going to try and emphasize many times is that just like we saw in our discussions with transformations in general, we always have to be careful about the b value, and that when a b value is written with the x, it must be factored out. So I just want you to write a little note about that. I will always remember to factor out the b value. So if you look at the example I have over here, initially it's written as 2 sine x and a 5x minus 150. So initially, a student that's not as wise as you would say, oh, that b value is 5, so this has been horizontally stretched by 1/5, and then it went to the right 150 degrees. When in the case, that's a lie, because it's actually been horizontally stretched by 1/5, and it goes right 30 degrees. So I will remember to factor out, and we'll see that come across our situations many times, right? And there's a summary, and we don't really need to go through a lot of this, but you can look that over and highlight. It's basically the same transformations that we've already done. All right. So when we look at considering the equations, and now we're going to have specific equations now where we're given transformations and we have to write it. So what does a cosine equation look like if it was shifted with a phase shift of 75 right? Well, clearly it would just be cos x minus 75. What if it went up 4? Well, and it went 3 pi over 5 left. Notice they're mucking around with radians now, right? Well, obviously it would be x plus 3 pi over 5 plus 4, okay? And now we're putting all this stuff together, okay? So now we're dealing with amplitude, period, phase shift, and vertical displacement. All the conditions that we've now done in lessons 7 and now 8. So as you do each of these, I want you to write down what each of those are. So in the first one, the amplitude is 2. I chose to do this pi next, and the phase shift was pi left. The vertical displacement was 4 down, and the period, and as you do this, the period always starts off with 2 pi. But because this is 3, my period was multiplied by a horizontal stretch of 1/3, making the period then 2 pi over 3. Okay? If we continue on, we can see that, we go through them in order, we can see that the amplitude is clearly 2/3. But we also, with that goes a reflection in the x-axis. We'll go in order this time. I can see my period is always supposed to be 2 pi. However, I can see that my b value is 1/4, and so it has been horizontally stretched by 4 over 1. That makes my new period 8 pi. This is going to take a long time for that graph to complete. What else has happened? Well, it has a phase shift of pi over 12 to the right, and it's obviously gone up 3. Okay, so the trickiest thing usually is finding the period. In number 5, I don't know if we need to do both. I might do them both quickly, but we'll just go. The amplitude here, obviously the amplitude's 2. We don't usually have any troubles. But if you don't remember the note, look closely at this and realize that that b value causes a problem. And if you don't rewrite this question like this, you're going to be wrong. Y equals sine, you must factor that 3 out of there. Oops, I'll put that square bracket here. You must factor that 3 out of there. 3 bracket x plus pi over 3 bracket minus 4. And now you can complete the question successfully, because now when I go to calculate my period is always equal to 2 pi, except this one's been horizontally stretched because of this 3 by 1/3. That's the stretch factor. So therefore my new period is 2 pi over 3. What's my phase shift? Well, you would have wrongly assumed that it was pi to the left, but it's actually pi over 3 left, and it is going to go vertically translate down by 4. Okay? And in this one, I'm not going to go through all the steps because you can do that, but you do have to remember that you have to factor that out. So if I do factor that out, I take a 2 out of there, and this is going to be x minus pi over 4. It's a little trickier, and so the phase shift is pi over 4 to the right. Okay? All right, so now we're in example 6, so we continue on. And I guess the difference now is not giving you an equation. You have a graph, and you kind of have to read off the things from the graph and put them into the equation. Put A and C into the equation. So from this equation, they're telling us first off that A has got to be greater than 0. So in other words, they're saying I need to come up with an equation with an A and a C with the minimum possible phase shift. So they're really saying, well, A greater than 0 really means, and I'm going to put this over on the side, from lesson 6, remember what you learned, that sine starts at 0, goes to 1, back down to -1, and that is regular happy sine. Sine x where A is greater than 0. And I'm going to put this over here too, folks. You need to have that sheet, because when you have normal happy cosine starts here, and these were our critical points. Remember, 0, 0, 0, 1, 0, -1, and so on. And so this was regular happy cosine. And that's going to be important. That's the key to doing these questions. So when I look at this question and it says, hey, they're telling me go find happy sine, then they are saying that this would be normal sine right there. That is one period of sine. I found it. It's been shifted. Now, there is also another one back here that's been shifted to the left, and it would have started somewhere way back here, but that's not a minimum, right? That's not a minimum phase shift. So I'm going to go to this point here, and I'm going to look at this, and I'm going to say, based on my first graph, how has that been changed? Well, how has normal regular sine been changed when we consider those key points where this is 1, this was -1, 1 and -1, and their periods were both to 2 pi, right? So how have they been changed? Well, if I look at this graph, I have to look at the scale and decide, well, what's my period? Well, I look and the scale says that I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 spaces. And each of those spaces is, I got to check. Well, each of those spaces was actually pi over 6. And so each of those spaces was pi over 6. So that meant that my period, when I counted, was 12 pi over 6, which equals 2 pi. So there hasn't been, and I guess I would have known that because there was no v value there, right? So now I really just need to check, because of the a, what's the amplitude? And I can see that my scale is 1, 2, 3, 4. It's a 1-to-1, so my amplitude is 1, 2, 3, 4. So because my amplitude equals 4, then therefore a would equal 4. And secondly, what's my phase shift? Well, my phase shift, I'm going to use, that's my imaginary axis. My phase shift went 2 spaces over, 1 and 2. So my phase shift is actually 2 spaces, which would be 2 pi over 6, or pi over 3 to the right. So what's my equation? Therefore, my equation is y equals 4 sine of x minus pi over 3. And all is good. Okay, and now we kind of know the pattern, so we do the same thing with each of these. Now it says write the same equation for the graph of a sine, but now a is not happy. Really? So it's the same graph, but now you have to find a new starting point because a is not happy. Well, if you look back at your graph, what would sad sine look like? Well, sad sine, if you reflect it, right? So you need to reflect it in the x-axis. That's what an a value less than 0 does, reflect it. What would that look like? Well, it would start at 0 and go down, right? So instead of starting and going up like it does, it starts at 0 and goes down and returns. So that would be one possibility. Or you might say, well, Mr. K, wouldn't it be okay if I went here and completed it? And that's true too. The key is we want the minimum possible phase shift. So it's exactly the same graph as the one above, but now they're just saying, well, now we have to have it sad. So which one is minimum? Is this phase shift minimum or is this phase shift minimum? Well, we've got 1, 2, 3, 4 spaces here and 1, 2, 3, 4, 5 spaces here. So it's this one here that's minimum. This is 4 pi over 6 left. So when we look at it, the graph still has an amplitude, right? The amplitude is still equal to 4, so my a value equals 4, except for now it's going to be minus 4, and my phase shift is going to equal 4 pi over 6 left, or 2 pi over 3. And therefore, we're going to have y equals 4 sine bracket x plus 2 pi over 3, so that we end up going 2 pi over 3 to the, that said minimum possible phase shift. I guess another fairly good answer would have been, hold on here. So I'll just a refresher. So what we were looking for in this case is we were doing exactly the same graph, but we were finding, oh no, minus 4. What we were looking for in this case was not normal sine, but reflected sine. So we were looking for a graph that looked like that, right? and where that happens in the picture, right? Kind of like how to find Waldo. So in the next one, we still have the same graph. Oh my gosh, but now we're looking at cosine. And in this one, I want you to try this one on your own. In this one, you are looking for happy cosine. So you're trying to take a crayon out, and in this case, look for happy cosine. What does happy cosine look like? Happy cosine looks like this. Starts at 1, goes down to -1, back up, right? And that all happens from 0 to 2 pi, and this is 1, and that's -1. In the second one, find the equation if you were wanting to base your equation on a reflected cosine, which would start low and end low, and it would go to 2 pi, and this would be 1 and -1. Okay, so you're still looking on the same graph. So when we go to, well, where is that? Well, obviously, the cosine graph that's happy with the minimum phase shift, there's a couple possibilities. You could start up here and say, well, it'll finish there. But it probably makes more sense. That's a big phase shift to start way back here. So I think it would be a minimum phase shift if we started right here. And what does that make? Well, it makes 1, 2, 3, 4, 5. So that's 5 pi over 6 to the right, and we still know that the amplitude is 4. So this would be 4 happy cosine bracket x minus 5 pi over 6. And in the second one, how do we find sad cosine? Well, that was easy to find. Sad cosine is best located right there. And you can see that that would just be pi over 6 to the left. And so now we're going to have y equals -4, because the amplitude is still 4, -4 cosine x plus pi over 6. All right. Hopefully we're starting to get the hang of it, right? Okay, so now you have a different graph, and notice I've already done some of it. As you read these things, you have to start by underlining the key things. So this is a sine function. You are looking for, and it says sine greater than 0. So this is your target. How do you find Waldo? How do you find the trig graph? Oopsie, let's not make that red. I am looking for, at the heart of this, regular sine, happy sine. Right? So compare the table with the graph and the equation, and now try and find it. So here's my target, right? I can see that is normal sine. Based on that, right, we put our crosshairs. This is my imaginary axis. This is the middle of my graph, that red line, and this is the boundaries of the periods, right? So when you say to yourself, well, I could count up the period. I counted it up top by the peaks of the graphs, but you could also count them by looking at, well, where does sine start, where does it end? So I could count the spaces it takes to get from here to there. And so if I count the spaces up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Those are 12 spaces, and I was counting up here. It's 12 spaces, but you have to know the scale. What is each of those? Well, when you think it takes 1, look up at on the x-axis, it takes 1, 2, 3 units to get to pi. So that means each of those units is pi over 3. So 12 pi divided by 3 means that this graph has a period of 4 pi. The period is 4 pi. Great. What's the amplitude? Well, that's pretty straightforward, but you still have to not make assumptions, because every space is not 1 unit. Notice it's 1, 2, 3 spaces to 1. So every space is actually a third. So when you count this up, the amplitude is 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces. So the amplitude is 9 times 1/3, right? The total distance of the heights of the peak is 3 units. What is the minimum horizontal phase shift? Well, where we've drawn it, it looks like it's one space. It's one space to the left. So each of those was a third. So this would be pi over 3 to the left. And the vertical displacement, well, based on where you see the midline of the graph to be, this graph is 2 units down. 2 down. So now we have to put this information into our equation, right? Oh, maybe they didn't tell us to, oh, we have to write the equation down there. So when we go to write the equation, the only thing that's tricky is this period. Remember, the period is not the b value, right? The period's not the b value. My period is always equal to, normally, 2 pi, unless we multiplied by some b value. So the period multiplied by 1 over b is equal to, in this case, 4 pi. What was b? Well, b must have been a half, and you could cross multiply or use common sense, but 2 pi over b equal to 4 pi, that means that 4 pi b is equal to 2 pi, and if I solve that for b, b equals 1/2. And you might say, well, I'd like you to do this, Mr. K. 2 pi divided by 4 pi equals 1/2. Okay? And therefore, the equation of this is equal to 3 times the sine of 1/2 x plus pi over 3 minus 2. Okay? And don't forget, you have to write the b value factored out. Okay? I'm going to emphasize that again. Okay? You have to write it outside. Right? We could go through another one. If the graph was cosine, and I believe this is the same graph. Now the good part is the amplitude's going to be the same, so I won't go through that again. So the amplitude's still going to be 3. The period, I'm not going to go through that again because period for sine and cosine same. So the period here is still going to be, in this case, 4 pi, which makes that b value equal to 1/2, like I already showed you. The phase shift is where things can kind of happen and change. So the phase shift, we have to look for happy, in this case, happy cosine, and happy cosine looks like, well, we talked about that, I shouldn't really be showing you again. Oops, not that. Happy cosine, yeah, that was it. Happy cosine looks like that. So if happy cosine looks like that, that's the target that I'm looking for. I should put that in blue. Okay. So if that's happy cosine, I've got 2 spaces to the right, so the phase shift is 2 pi over 3, right? And the vertical displacement, it's going to be the same, right? The vertical displacement is still going to be down to, because this middle, right? If I draw that midline, and now there's my beginning and end of my period, and my vertical displacement is still going to be down by 2. And I wrote the equation for if a was greater than 0, but these tricky guys wanted it for a less than 0, so I'll just give you that one as well, and you can check it out. So that would be minus 3 cosine. You'd still have a half here, but that would change your phase shift again, and the phase shift would end up being plus 4 pi over 3, but you'd still have the minus 2. So this one would be, and I'll put this one would be for a as less than 0. Okay? And you can ponder number 8. You can ponder number 8, and we'll discuss that in class. How do these parameters affect domain and range and so on? So hopefully you pondered that and you've written some answers down. And this is a very likely kind of diploma exam question because it shows some deep understanding. So I'll give you the answers, and then I would definitely like you to get clarification if this doesn't make sense, right? So the domain, none of them affect that. Which of those values affects range? A and D. What's the amplitude? A. What's the period? What affects period? Just B. What affects the zeros, the x-intercepts? Well, B, C, and D all do. If somebody wanted to know the minimum of that, what would they do? Well, they'd go A plus D. What if they wanted, what they wanted to know the max, A plus D, and the minimum would be D minus A. And lastly, the range would be greater than or equal to -7, but less than or equal to -1. All right, take care, Math 30-1.